I'll, I'll be your MC and hope all of you are fine. First of all, on behalf of the APT, may I welcome everyone to this first episode of the Expanding Wireless Access Opportunity Web Dialogue Series. The topic for today's discussion is Wi-Fi 6E Overview and Use Cases. Today we have with us Mr. Masanori Kondo, Secretary General of Asia Pacific Telecommunity, Ms. Martha Soares, President of the Dynamic Spectrum Alliance, and of course our distinguished speakers, Mr. Mark from Cisco and Mr. Hassan from Intel. This web dialogue series is brought to you by Asia Pacific Telecommunity in collaboration with Dynamic Spectrum Alliance. Before we begin, some housekeeping rules. Please keep your mic turned off during the presentation. Please state your name and country in the Zoom user level so that we can identify you. We will take your questions for both the presentations together at the end. We will provide a short recap of the session as well at the end. You are kindly requested to raise your hand using Zoom feature or drop the questions in the chat box. However, we encourage you to speak for yourself by turning on the mic. Without further ado, may I now welcome Mr. Masanori Kondo, Secretary General of APT, and request him to kindly deliver his opening remarks. Mr. Kondo, please.
Okay, thank you, Nidep. So good morning, good afternoon, and good evening. I'm pleased to welcome you all to this APT Web Dialogue. So first of all, I'd like to express my sincere thanks to Ms. Martha Soares, President of the Dynamic Spectrum Alliance, DSA, for her presence today. Dynamic Spectrum Alliance is the sponsor of this APT Web Dialogue series of Expanding Wireless Access Opportunities, so-called EWAO, which includes 3 episodes starting today. I sincerely appreciate the support and contribution of DSA to APT Web Dialogue. APT launched this APT Web Dialogue platform with the aim to provide a platform for sharing information, knowledge, and experiences. This is a place to serve APT members' intellectual appetite for learning something new and more. APT has been organizing APT Web Dialogues in collaboration with our partners, including individual APT member countries, academia, and industry. There are also a series of dialogues focusing on a specific topic of ICT services and industries, such as spectrum management. Today's dialogue is the first episode in the series of Expanding Wireless Access Opportunity. I understand that many of today's participants have already registered for all episodes of this series. Each episode will provide new perspectives from various aspects of wireless access, especially Wi-Fi 6E, and I believe they are useful and insightful for the participants. Once again, thank you for joining us today, and I wish you all a fruitful discussion. Thank you.
Thank you, Mr. Kondo, for your opening remarks. Let us now welcome Ms. Martha Soares, President of the Dynamic Spectrum Alliance, to provide her remarks. Ms. Martha, please do us the honor.
Thank you so much. On behalf of the Dynamic Spectrum Alliance and our partners, I would like to thank APT for allowing us to participate and to organize with you this web dialogue series. We really appreciate the opportunity to share experience and knowledge and last information from industry. And we hope that this series will really provide insightful information and valuable inputs for all the participants about the different subjects that we will be discussing. So the general subject here is expanding wireless access opportunities. And we will have 3 sessions focusing on overview and use cases today. On the complementarity between Wi-Fi 6E and 5G in the second session. And at the end, we are going to talk about standard power Wi-Fi and AFC, automated frequency coordination systems. I would like to mention and highlight that this is, you will have speakers not only from members of the Dynamic Spectrum Alliance, but also from different partners that are also supporting this important subject in the region. So it's really a wider industry position that you will hear in this web dialogue. I took the opportunity also to highlight the tremendous momentum that we are seeing globally and regionally in terms of the 6 gigahertz band for unlicensed access. To give you an overview very quickly, in the Americas, we have so far 8 administrations that have enabled unlicensed access to the entire band. And we have 4 new administrations that are had public consultations. And the most recent one was this week, a new consultation from Dominican Republic for the entire band. This tremendous momentum is also seen in different regions. So in particular in APT region, we are seeing, we had seen first, the first adopter of decisions was the Republic of Korea that decided to open the entire band for license exempt access, for unlicensed access. And that was like starting point, very important from one of the global leaders in terms of 5G. So really demonstrating that complement between the two technologies. And then in the last 5 months, we have also seen a tremendous activity in this band with recent decisions from Australia, Malaysia, Japan, Hong Kong, and from those countries, and Malaysia, Australia, Japan, Hong Kong. And we have also seen consultations in other administrations in the past from Taiwan and from New Zealand. So that demonstrates the interest and how important this subject is for the region. And today we would like to cover with our presentations the why it is important to consider this band for unlicensed access and for the new generation of Wi-Fi, Wi-Fi 6E and Wi-Fi 7. The what should be considered, what the technology is, what is proposing and enabling, and finally the how. So how it could be facilitated and how those networks are really going to create value for Asia Pacific countries in terms of citizens, but also in terms of enterprises and companies. So with that introduction, I would like now to give back the floor to the organizers. Again, thank you so much for this opportunity.
Thank you, Ms. Soares. Pleasure having you with us today. Before moving on to the next session, we would like to have a quick photo session. So I would like to request all the guests and the participants to kindly open your camera and show your beautiful faces. So I'll request my colleagues to take the photo. So give us 1 to 2 minutes. Okay, thank you, everyone. Now let us move on to our next session. What is Wi-Fi? Not a difficult question, right? You are well aware of what it is. Wi-Fi has become an integral part of our life, whether you're at home or at work or universities or almost everywhere. Today, you cannot imagine life without Wi-Fi. And if I ask you, it will be difficult for you to find any device that does not rely on Wi-Fi. Likewise, businesses can't function without Wi-Fi. So how important is Wi-Fi and what are the developments in this field? So that's exactly what we are going to see in this 3-episode APT web dialogues. Without further ado, let me introduce our first speaker, Mr. Mark Krischer. Mr. Mark Krischer is a principal wireless architect, Cisco Asia Pacific, Japan, and Greater China. Mark has over 25 years of experience across mobility and security technologies, and he has joined Cisco in 2001 as part of Radiator Acquisition, and he was the director of software engineering. As part of Cisco's wireless networking business, Mark led the Sydney Software Engineering Group and was responsible for the design and development for such technologies as EAP Fast, IETF, RFC 4851, and management frame protection. Prior to his involvement in the wireless, Mark focused on intrusion detection and application of public key infrastructure to secure the network protocols and services at BBN Technologies. Through his engineering work, Mark holds 18 patents in wireless and security. What a great feat, Mark. The floor is yours. Thank you.
Thank you very much, and really appreciate the opportunity from both APT and the DSA to present to you all here today. Let me just bring up the slides and we can get things started. So my colleague Hassan and I, we really want to take the view of Wi-Fi 6E and to the point that Martha raised, really do it from the perspective of the why, the what, and the how. And so to kick things off, I really wanted to start with kind of where things are today and, to the point of how are we seeing the scale of how Wi-Fi is used today? And I have two examples I wanted to start with. The first one is from a recent major sporting event in the US. Some of you may be familiar with the Super Bowl. What this was really looking at was the scale of the data traffic that was seen across this event. You can see that the numbers there pretty huge. 53 petabytes of data, and this is on the wired network for their video, their media network. And what that was driving was they had about 40 4K video units across the environment. So even if you're up in what they call the nosebleed seats, you're still able to see what's going on. But the interesting thing of how they're extending that video is you can also stream that video. You can share that video from your own personal device, and that's what we saw growing the utilization of the Wi-Fi in the environment, and how all the different people in the stadium we're actually leveraging Wi-Fi for internet connectivity as well as the local video connectivity. You can see there, over 30 terabytes of internet traffic. What's interesting in that is if you look at the previous Super Bowl event and you look, at the similar utilization within the stadium during the game, it was roughly about 15 terabytes of traffic. And what that shows you that that doubling of the data goes to not just how many more people and how many more devices are coming onto network, but again, the applications that are now being used, particularly as we look at the rise of ultra high definition 4K video. When you look at that number, the number of clients, around 30,000 connected clients, this is where we're seeing just the scale increase at incredible levels. Now that's looking at a point in time. The other example that I wanted to look at was kind of the ongoing daily use of Wi-Fi. And the example that I have here is Houston Methodist Hospital. It's actually a group of hospitals across Houston, which is one of the larger cities in Texas. Interestingly, from some work I was doing with the Hong Kong Hospital Authority, I discovered that Houston as a city is roughly the same size as Hong Kong, though in Hong Kong they have about 4 times the population. So, if we look at the hospital group, they actually have a group of about 8 hospitals and a bunch of clinics and emergency operations. What they're seeing on a daily basis is over 55,000 devices. So we just looked at 33,000 just at the Super Bowl event. Here's a hospital group where they're seeing over 55,000 unique devices every day on the network. And that's not just the user devices from the doctors and the nurses and the patients and visitors. That also goes to the medical devices that are also on the wireless network. The interesting thing about this example is I've been talking about Houston Methodist in our work with regulators around the region for 2 years now. And 2 years ago, when I first started using this example, it was 35,000 client devices. So, again, seeing that huge increase just over the last 2 years. And so, what this says to us, and as someone who's been working in the wireless space for over 20 years now, I've always been amazed at just how successful Wi-Fi is, despite the fact that we have such little bandwidth allocated to it. We started with just the 2.4 gig band with only 3 channels. And then it was phenomenal when countries around the world opened up the 5 gig band, and gave us 500 megahertz. But as Hassan will talk about in the next session, there's challenges with that 500 megahertz. And so while we got a lot more channels, it didn't come without, some problems in and of itself. And so what I'm finding interesting is looking at why regulators around the world are opening up 6 gig and the journey that they are all going on as they figure out that this is the right direction. So the FCC in the US, which was the first country to open up the 6 gig band, they really recognize this idea that unlicensed devices are indispensable for providing low-cost wireless connectivity. And what that really goes to drive is economic growth for the country, because what unlicensed networks is all about is removing the barriers to entry to be able to take advantage. Anyone, anytime, anywhere that they need a wireless network for mobility, for connectivity, they can deploy a Wi-Fi network. Taking that one step further, then, the Europeans recognize that it's not just about the state of the technology today. They need to be thinking about what is required to support that long-term future. And again, that's where 6 gig came into play. And so, if we look at now what 6 gig is going to bring, this is about giving Wi-Fi room to grow. The potential for twice the available spectrum that we have with 2.4 and 5 gig today. Now, the issue is, countries are taking different approaches. Martha talked about how South Korea opened up the full 1200, but if we look at the other 4 countries that have opened up just in the last 5 months, they've taken a bit of a more conservative approach and only opening up the bottom 500 megahertz. And really that goes to some work that's being done and trying to understand what the best use of that top 700 megahertz is for, because there's debates now, do we use it for unlicensed use or do we use it for wireless broadband, for IMT? The challenge with using it for IMT, of course, is there are incumbents in that band, typically microwave and satellite links that are already using the spectrum. Interestingly, the ACMA in Australia noted that while everyone's waiting for the studies that are expected to be completed at the end of next year to really look at how well they can interoperate, from what people are seeing already, it doesn't seem likely that sharing is going to be feasible. And so the ACMA's position is, if that is proved to be the case, then class licensing or making available for unlicensed use, across the entire 1200 is what they're suggesting might be appropriate. Interestingly, Canada, who did take the view of opening up the full 1200, their whole rationale behind it was to focus on spectrum sharing, recognizing that spectrum is a limited resource. And what they really need to look at is how can they allow multiple technologies to share that effectively. And they just saw the 6 gig band as a great place to really test out that theory. And in episode 3 next month, my colleague from Broadcom, will be doing, talking about automated frequency control and AFC, which really goes to how we can make that happen. So the other piece, though, if we think about the move to 6 gig, it really is not just about what we need today. It really is, where do we see the technology and the applications going? And one of the things that you see talked about a lot is mixed reality, augmented and virtual reality, and lots of people looking at how we can evolve. What we're doing today, a video conference. How do we evolve that, make that more immersive, allow it to be more collaborative with augmented and virtual reality? How can we enhance training opportunities? And these are just simple examples and looking at more one-to-one engagements. But we really need to think about how we scale that. How do we get to the point that potentially everyone is using augmented and virtual reality, just as everyone has a smartphone today? And so we start thinking about what is required to make that scale. Now, a lot of those examples, people say, oh, well, that's not here today, that's in the future, an element of science fiction, and that's fair enough. Actually, a great example from Microsoft using their HoloLens technology. They actually were enabling telemedicine up into the International Space Station. But the real question that our customers are having is, what's real today? How are people making use of this technology today? And the important thing to note is that we are seeing a huge amount of work by organizations, enterprises, leveraging VR and AR for real business outcomes. One example here in Australia, in both Queensland and Western Australia, they are looking at VR to help facilitate training of police officers, allowing them to immerse the officers into different situations to help with the training of how they respond to different environments. In the mining space, VR being used to train both operators on how to operate heavy machinery, but also for control of automated vehicles when they need to go into a manual control scenario. That one's particularly interesting because we're not just looking at what's required to support VR, where the operator will be, but also think about where the vehicle will be. We now need to have full 360-degree high definition, ultra high definition video, and we need the network to be able to support that video to connect to the operator with VR. Training is a real major area where we see this being used. Interestingly, if you look in the aircraft space, obviously for a long time, they've been using simulator technology to train pilots. Now VR allows them to scale that down, make it a bit more feasible, but also on the maintenance side. So it takes about 18 weeks to train someone to do repair on a helicopter. And part of what that's tied to is just the reality of when can we give that trainee access to the helicopter. What they're finding is if we can give a VR headset to that trainee, that allows them to reduce the time that it takes, because that VR headset is effectively giving them their own personal helicopter to work on. That allows them to reduce the time. And so, the point here is there are genuine business benefits and business outcomes that are being enabled by these technologies. Augmented reality is another example of where really cool innovation is happening. And this is not just, within the last 6 months that all these things have been starting. This example comes from 2 years ago. Johns Hopkins Hospital performed the first augmented reality assisted spinal surgery. What this is about is for spinal surgery, normally they will do a CT scan of the patient and they'll use that to plan the surgical procedure. And in the normal approach, you'd have a screen to the side. And so the surgeon would be looking at the patient in front of them, checking out the screen to the side and making sure they are aligning what they are doing properly. AR allows them to overlay that CT scan right into the visual scope of the surgeon, just increasing the the benefits and ensuring that the surgery goes without fault. So, that's looking from these extreme cases, some real interesting outcomes. But the other piece, and reason I like the augmented reality side to focus on is because unlike VR, you don't necessarily need a dedicated headset. There are examples of AR being used just with our smartphones and tablets today, and a whole range of different applications from what I like to call information overlays, providing additional information on what you see in front of you in a whole range of different use cases, or what I like to call virtual visualization. So, for example, allowing a new bride to try on wedding dresses or check out wedding rings, allowing you to visualize what a new real estate project might look like, or what a piece of furniture is going to look like in your home. And so we're seeing rapid adoption at the application layer to take advantage of these technologies. Now, one of the things that comes up whenever we talk about AR and VR is, oh, but why can't we use 5G for that? And 100% you can use 5G for that. In fact, we're seeing a lot of movement and adoption specifically in the private 5G space, specifically in the industrial space. And here's some examples of Cisco WebEx together with Google Glass looking at providing on-demand expertise. Now, the reason I use this as an example of why Wi-Fi and 5G really benefit from operating together is because at the moment, we don't have headsets that support 5G. And this just comes down to the chipsets, both in terms of cost, but also in terms of power and heat dissipation. You need to design a headset that is not going to get too hot, so it won't be uncomfortable. It needs to be lightweight. And you need to have enough battery life, that I can wear it for an extended period of time. And at the end of the day, that's simply not feasible with 5G. It's feasible with Wi-Fi 6 and 6E. And so the implication of that is we still use Wi-Fi for access connectivity, and then 5G is really a great complementary technology for the backhaul. And to that point, I just really want to go back to what I said at the start about Wi-Fi really driving economic value because it removes the barriers to entry. I don't need to go and get a license in order to create this network. I don't need to work with a service provider to get access, where I need to have that connectivity. I can just go get an access point, bring it up and running, and I have the connectivity that I need to drive that innovation and that growth. And that's what's driving the value of Wi-Fi to the tune of $3.3 trillion last year. That's looked to up to $4.5 trillion over the next few years. And looking at the value of that and how it ties into, again, that synergy with 5G, because lots of mobile traffic is offloaded to Wi-Fi. That stadium example at the start, right? They simply can't scale to mobile broadband, given the number of people that they have in that stadium. They need to be supporting it with Wi-Fi. And so Wi-Fi 6, huge amount of growth, and we're already starting to see that happen. And again, my colleague Hassan is going to show you a little bit about what we're seeing in that space. So without further ado, I'd like to hand off to my colleague Hassan from Intel to talk a little bit about the what.
Okay, thank you very much, Mark, and many thanks to APT and DSA for giving the opportunity to present here. Let me share my screen. Okay. I'm glad to present to this forum an overview of Wi-Fi 6E, Wi-Fi 7 technology and use cases as related to different modes of operation. Okay, let me go to all right. So an outline, I will provide an overview, quick overview of Wi-Fi 6, release 1, 6E, release 2, then an overview of Wi-Fi 7. We talk a little bit about the Wi-Fi technology spectrum evolution, like to add to what Mark covered in this session. a little bit information about the handling of determinism and reliability, how the Wi-Fi technology is evolving to address that. And then we talk about the different modes of operation for 6 GHz band in Wi-Fi 6.7. And then I have one slide on AFC. As Mark mentioned, we have a session later that our colleagues from Broadcom and HPE will cover the AFC in details. So let's go start with the Wi-Fi 6. Here I have the focus area and features of Wi-Fi 6. Wi-Fi 6 basically was enabled in phases. We had Wi-Fi 6 release 1, that were the certification for those devices started in 2019. Then we had the Wi-Fi 6E certification that started in January of 2021. And then we have Wi-Fi 6 release 2 with the certification that recently started, like earlier this year in January. The focus improvement for Wi-Fi 6 is to address the performance needed for dense and congested environments like airport, train stations, stadiums, mall, education, public transportation, citywide Wi-Fi, apartment buildings, and Pico cell street deployments, all those use cases and deployment scenarios. And also it continues improving the Wi-Fi conventional markets and usages for connectivities, including home and small office environment. And this is done through increasing the peak data rate and more efficient MAC signaling. Like on the left side, I have a list of features for Wi-Fi release 1. In Wi-Fi release 1, the downlink and uplink OFDMA was enabled and supported. That is to enable scaling and also improve the latency. Also, multi-user MIMO in downlink was enabled in release 1 to improve the efficiency and also scaling. Again, higher order modulation like 1K QAM, MCS level 10 and 11 was also enabled to improve the spectral efficiency and throughput. With regard to spatial streams, in Wi-Fi 5, we had maximum of 4 spatial streams. In Wi-Fi 6, we are supporting a maximum of 8 spatial streams. And also for reuse operation, like to improve and better manage interference, the BSS coloring feature was added. Transmit beamforming was another main feature in release 1 to basically, again, improve the efficiency, spectral efficiency, as well as ranges. For 6E, of course, the target improvement was to enable the 6 GHz band, 5925 to 7125 megahertz, targeting higher throughput, higher network capacity, and spectral efficiency. And the last for release 6 was for Wi-Fi 6 was release 2. In release 1, the downlink multi-user MIMO was enabled. In release 2, uplink multi-user MIMO was enabled, again, to further improve the spectral efficiency and also target wake time, a feature to improve battery life was enabled. And for the first time, a version of preamble puncturing for up to 40 megahertz puncturing was enabled to improve coexistence with the incumbent services in the band. And that's something that we talk about in more detail later. Okay, let me go to the next slide. So overall, that's what we can get from these features: 4 times greater scalability through enabling of OFDMA to efficient connectivity across more devices, reduce interference through the BSS coloring to better manage interference and prioritize interference between different BSSs. Improved security was another feature. WPA3 was enabled in Wi-Fi 6 to enable the next generation authentication and best-in-class encryption. As far as the throughput performance is concerned, we are getting 3 times faster, faster performance through enablement of like the 1K QAM, the 160 megahertz channel that we talk about a little bit more later, to enable gigabit speed for home and office. And the last but not least, like we have the, okay, I'm sorry. We have the lower latency, improvement in latency, with the introduction of OFDMA and also BSS coloring, we are improving. And of course, like the enablement of 160 megahertz channel, we are improving the latency by 75%. Okay, let me go to the next slide. Okay. Just a second. Okay, so here I am covering the scope areas and target features for Wi-Fi 7. The main focus area is to improve performance in environment that that demand high performance, like peak throughput, high network and link efficiency, increased reliability, and low latency. That last two basically performance measure are very important and unique to Wi-Fi 7, reliability and low latency. And of course, the Wi-Fi 7 is targeting the same type of use cases and environments as we mentioned for Wi-Fi 6. But in addition, we would like to highlight like application industrial IoT, AR, VR, XR, those type of applications. In the middle of the slide, you see the support for the channel bandwidths in the 6 gigahertz band. Mark covered that, like there's a little bit more detail here. As you see here, we are able to support up to 7, considering the entire 6 gigahertz band allocated to Wi-Fi. We support up to like 7 of these 160 megahertz channels for Wi-Fi 6, and also in Wi-Fi 7. We can support up to 3 of these 320 megahertz channels in 2 different configurations. The one configuration basically has a shift relative to the other one to basically start 100 megahertz away from the channel edge, lower channel edge, in order to address regulatory requirements or device like design requirements. There are 2 options with the channels. At the bottom of the slide, I'm trying to introduce the multi-RU puncturing feature that is supported in Wi-Fi 7. This feature is to address coexistence with incumbent services. As you see here, we have this channel 31 that we need to coexist with an incumbent in the middle of the channel. And because of the puncturing feature, we can puncture the basically the transmission in the channel 31 to accommodate incumbent. At the same time, we are still enabling the 320 megahertz channel for efficiency. So that's basically this slide. Let me go on to next slide. So here I have a number of additional key features for Wi-Fi 7. On the top left, I have the multi-link operation in the supported in both AP and stay clients. This is a MAC aggregation of basically traffic, like between the, for example, between the 5 gigahertz and 6 gigahertz band. The aggregation can happen like on the stay or on the access point. With this, we are improving latency, we are improving basically throughput of those features, all those performances. In the middle top, I have the multi-AP coordination that can happen in different forms and different flavors in the MAC layer or PHY layer, and that is in general to improve network operation and network performance. Top right, I have the 4K QAM. If you remember, in Wi-Fi 6, we were supporting the 1K QAM, MCS 10 and 11. Here we are supporting 4K QAM, MCS 12 and 13, and of course we get the associated like a spectral efficiency improvement for those scenarios that can basically support basically these 2 MCS levels. In the middle, I have the 16 specialist stream. Again, in Wi-Fi 6, the support was maximum 8 specialist stream. In Wi-Fi 7, the target is to enable 16 special stream. And then on the bottom part, on the left and right, I have some performance improvement data. On the left, I have the data rates, like assuming 320 megahertz channel, 4K QAM, 16 special streams. For a peak data rate, we can improve the peak data rate by a factor of 5-6 relative to the 10 gigabit per second or so, 9.6 gigabit per second that we can do in Wi-Fi 6. And on the right, I have the deterministic low latency enhancement and reliability. In Wi-Fi 6, we can achieve a single-digit millisecond latency, but worst-case latency can be high in congested environment. So we need to improve that to have like the low latency performance in basically high percentile scenarios. In Wi-Fi 7, the multi-link operation that I mentioned earlier, the multi-AP feature, and also 320 megahertz enables basically us to have improved latency for like a 90% percentile or something like that. Okay, let me continue. Okay, here I would like to talk a little bit about the like a spectrum, like the support for 5 gigahertz spectrum. So in Wi-Fi 5 and Wi-Fi 6 R1, both the 80 megahertz channel bandwidth is mandatory, the support of those. And also the support for 160 megahertz channel bandwidth is optional. But there are some challenges with respect to support of these wide channel bandwidths in the 5 gigahertz band. In the figure, I'm trying to elaborate on that. As you see, we have the DFS incumbent in the middle of the band from 5,250 megahertz to, there's a typo, that's not gigahertz, megahertz, to basically to the upper bound for the DFS, which is 725 megahertz. In this region, because of the coexistence with DFS, we need to treat the incumbent properly. There is an inefficiency that comes to the picture from the performance perspective because of that, and there are also issues with respect to the support of in the products for the same reason. In this band, we also have other basically coexistence scenarios, like for channel 120, 124, 128, we have the TWR basically radars. And as a result, we have restrictions on covering like or enabling large channel bandwidths such as 80 megahertz and 160 megahertz in some areas, in some regions globally, at least. And then we have some legacy issues on channel 144 that basically, again, may cause some, not all the devices or products support the channel 138. In the lower part of the band, considering the channel 50, 160 megahertz channel 50, we have this straddling situation between the Uni1 and Uni2A that introduced some inefficiency and problem with enabling channel 50. On the upper portion of the band, we have the Uni3 and Uni4, internationally 5725 to 5895. There is a lack of global harmonization on that. Of course, the Uni4 is adopted for unlicensed operation in US, Canada, and Canada is working on that. But because of the lack of global harmonization, there are challenges with respect to support of large channel bandwidths here. So that's the general picture. We have all these, we have these challenges in 5 gigahertz. And then looking at what we presented in the earlier slide, we have the IEEE 802.11 standard, and we have Wi-Fi technologies and all the features that are provisioned to basically offer and provide the performance, like throughput and latency performances for a session of any of these applications. But when we think about scalability, as Mark mentioned earlier, when we want to scale for enterprise solution or industrial solution, education, health, and all those high traffic congested like deployment, like venues and things like that, then we really need multiple channels. Like even if we can accommodate one channel in 5 gigahertz, basically supporting the those scaled version of deployment is require enabling multiple channels. The situation that we have for Wi-Fi 6E and 7, because of the introduction of 6 gigahertz band, is different. As we will talk later, there are modes that are designed for special modes that are designed for 6 gigahertz band operation to properly to optimally address coexistence with different types of incumbent. As a result, assuming that the entire 6 gigahertz band is adopted, we can accommodate multiple wide channel bandwidths of like 80 megahertz, 160 megahertz, and 320 megahertz. And that's the key to the success for scaling for enterprise and also all those industrial deployment that we are working on. So I think the message is that we don't want to have the same situation that we have in 5 gigahertz. The circumstance in 5 gigahertz was special. We had to deal with a number of like incumbent scenarios and also different issues that I mentioned earlier. In 6 gigahertz band, the situation is different. We need to make a decision. Okay, so let me go to the next slide. This slide is trying to talk a little bit about the basically the how basically the coverage domain and target segments and applications are evolving in Wi-Fi. Of course, we currently have the home coverage in a global scale, primarily based on best effort, and the value is quality of life. Going to the enterprise and public solution to enable smartphone, tablets, laptops, smart building, campus, all like healthcare and all those features. Again, we have good coverage. We have and we have a global footprint. Again, you can consider it best effort, but there are some like level of performance that is required for like some applications for those type of enterprise and public usages. And of course, we are targeting productivity and digitization as a value. And then we are basically we are expanding the scope to industrial IoT and that we are ramping globally. And for that, we require high reliability, determinism, and the value is basically we can deploy in an agile fashion for all these applications. Now, going back to looking at what we discussed for Wi-Fi 6, there is a progression that you see here, and that is what Wi-Fi standard is trying to achieve toward the enabling the basically determinism and reliability for industrial IoT. In Wi-Fi 6 R1, we introduce optimal scheduling for uplink OFDMA, scalability through OFDMA, battery life improvement. Wi-Fi 6E, with the introduction of 6 gigahertz band, we have more reliability, clean, rogue-free, green field type of a spectrum. Release 2, we improve more for uplink MIMO, uplink multi-user MIMO. Again, we improve longer battery life and more reliability through preamble puncturing, and also other like features like to extend the range, like single user PPDU. Wi-Fi 7, the reliability and determinism is the focus area. We have a larger number of features that we are targeting to enable this, and DCM, dual carrier modulation, multi-link operation that I talked about earlier, are improving reliability through redundancy. And then we have the deterministic low latency type of quality of services that we can achieve through enablement of multi-IP coordination and scheduling, and also multi-link quality of services. So that's the general vision for improvement of this determinism and reliability with what we are doing with Wi-Fi 6 and 7. Okay, next I am covering different modes of operation. Complementary mode of operation in 6E and 6 gigahertz band. Of course, like this is the new approach that we have. The industry have worked with regulator, regional regulator, and carefully define different modes of operations to optimally design the regulatory requirements for different modes of operation to fully support coexistence with the incumbent. And for that, we have the low power indoor LPI. It's indoor only. It's addressing like indoor type of like residential and office type of application like that are listed here for like residential multi-AP mesh network, multiple dwelling unit, single AP network, high density enterprise network, and venues, and industrial IoT. The power level requirements for that is for worldwide adoption is 30 dBm in US and 23 dBm for EU and CEP. Along with the LPI, the client-to-client mode of operation for indoor only is being adopted, and basically this is to make sure that client-to-client operation in conjunction with LPI can be guaranteed with the performance that we can get from LPI network, and we don't have to switch to like another mode like that is VLP that I cover later. So that's the other basically other modes. Then we have the VLP that is for indoor and outdoor operation. It's targeting 14 dBm for EU and Americas, and also some regions are considering 17 dBm to accommodate 320 megahertz channel, additional 3 dB, and of course like all the features that are listed here, like AR, VR, like mixed reality, UHD, video streaming, high speed tethering, and in-vehicle entertainment are the target usages for that mode. And then we have the standard power modes enabled through AFC or any other type of like registration and coordination database system for indoor outdoor operation for higher power. It is already adopted in US, Canada, and some countries in Asia or Middle East are considering. And that is to support like 36 dBm power level, multi-gigabit per second outdoor coverage, park, stadium, multi-gigabit point-to-point, point-to-multiple rural connectivities, and low latency Wi-Fi calls, and all those next generation AR/VR type of application. There are some activities and there are some proceedings in US for the enabling the mobile AFC, which is basically the mobile version of the standard power, primarily for outdoor. And let me go to the next slide. Again, this is a quick slide. I don't talk a lot about that. As I mentioned, there is a session dedicated to AFC that we will have in, I think, episode 3. But here is giving some general picture. AFC is designed to protect basically licensed fixed services incumbent. It's a geolocation-aware spectrum database solution that coordinates frequency for all standard power APs. It could be indoor or outdoor that would like to utilize the higher power, 36 dBm. The idea is for each standard power AP to send its 3D geolocation to the AFC system, and then the AFC system basically does the calculation and frequency availability calculation for maximum ERP based on the interference protection criteria of next 6 dB I over N. And in this calculation, the propagation environment, characteristics of the incumbent fixed services, location of the APs, those are all taken into the account. In the picture, I have a scenario for an FS link with 30 megahertz channel bandwidth at 6160. There are two APs. One is in the exclusion zone of the FS, and the other one is outside the exclusion zone. As you see, in the case of the red AP, there are some channels that are blocked. There are some spectrum that that AP cannot operate, the red AP, because of the basically proximity to the FS receiver. And that's what the AFC system does to calculate the basically the frequency availabilities. There is no issue, like the green AP can use all the channels, and because of the location of the AP that is reported to AFC, and as a result, there is no blocking of any channels. Here I have a quick slide on the product availabilities. This set of a slide, 2 of them, that's as of like December of this year. There are more already in the market. We have already more than hundreds of like PCs and laptops in the market. They are all 6E enabled, and they support 6 gigahertz band. There are also a large number of other types of devices like routers, access point, standalone smartphones, and smart TVs, and other consumer products from different leading vendors that are already 6E enabled and supporting 6 gigahertz. And again, like these slides are not up to date. I'm sure the number of devices and variety of those are already higher. So I think this is my last slide. I just wanted to leave with a message, as I have been trying to cover, and also Mark did, the Wi-Fi, basically the 6 gigahertz band is enabled, and the standard is enabled, certification is enabled. Like I have some numbers here. Wi-Fi Alliance has already certified 2400 Wi-Fi 6 and 121 Wi-Fi 6E devices, and the expectation is that 20% of all Wi-Fi 6 device shipments will support 6 gigahertz in this year. And then we have, as I mentioned earlier, we have products different types and form factors of products, and then ecosystem there, all these standard activities, forums, and different segments of industry already supporting Wi-Fi, the 6 gigahertz band. And I think that's the last slide on my side. So with that, I don't know how we proceed. Is it Mark, continue?
So Hassan, there actually were a couple questions that I might just highlight before I wrap up with the last piece here. One in particular ties into what you were just talking about on AFC, and I know in episode 3 we'll have more details on AFC, but there was a question around how our confidence level and how we can guarantee that Wi-Fi will be able to interoperate with the existing incumbents like the satellite and the microwave link providers. Can you comment on that a little, Hassan?
Yeah, with regard to AFC, of course, the AFC system is designed to basically coexist with the terrestrial incumbent FS services and other special terrestrial incumbent. As I mentioned, the 3 modes of operations are designed to also coexist with other types of incumbents, including the satellite services. More specifically, like the power level restrictions, and also the spectral, like the antenna emission pattern restrictions are the features that are provisioned to coexist with satellite incumbent. As far as the AFC is concerned, for coexistence with terrestrial incumbents, again, I gave one slide, but I think we better wait till episode 3, where we extensively discuss this, where colleagues from Broadcom and HP present.
Yeah, and there'll be a lot more detail there. But and the other piece is there were a considerable amount of studies that went into the decisions by the FCC in particular, as well as Europe around this. So there's been a lot of work and studies, around to show that they are confident. And of course, with AFC, that work is already being done in the US now, but to your point, Hassan, we'll hear more in episode 3. The other 2 questions were also interesting and go directly to what I intend to cover in this last wrap up. So we've covered the why and now the what. And so what I'd like to do now to kind of wrap things up is to touch on the how. So the 2 questions, that I thought were really good was one, what is it that we're saying, what are the applications that 6E is required for? Do we need 6E in order to enable these emerging use cases? And the other one was really looking at, well, why isn't the 500 megahertz enough? Why do we need that full 1200 megahertz of spectrum? And so I want to start just by looking at technology transitions in general. And so, if you look at average broadband speeds globally, as well as here in Asia Pacific, it's nothing that we're not, that we're surprised by, right? We expect to see the broadband speeds increase. And that's because work is being done at every technology layer to continue that growth. Wi-Fi 5 to Wi-Fi 7, Hassan just talked about to Wi-Fi 6, and Hassan just talked about Wi-Fi 7, 4G to 5G, and we know that 6G work is already beginning on the cable side, DOCSIS 3.1 to 4.0, and the improvements in fiber optics. The important thing to recognize here is you need to ensure that no single technology becomes the bottleneck. And so, if I look at a home, a consumer environment, right, even if I do have some, access to mobile broadband, 4G, 5G in the environment, there'll always be places where the coverage, doesn't give us what we need. Here in my house, if the NBN network to my home goes down, I have real problems because the 4G, 5G coverage in my area is just too poor. And that just goes to the realities of deployment. You're not going to get blanket pervasive access everywhere. And that's the whole point of why we need to be able to throw up a Wi-Fi network whenever and wherever we need. And so whether it's 4G, 5G or cable, providing me that access into the home, typically it's going to be Wi-Fi that is disseminating that connectivity around the home, and not just for my phone and my tablet, but for all the devices in my home environment. And so what then we start looking at is, all right, so what are we seeing today? If I go and deploy a Wi-Fi network today, and now I'm going to move from the home to the enterprise space, what are the challenges that we already see? So Hassan did a great job talking about the ability to do channel aggregation or channel bonding, which we can do in Wi-Fi 6 today. In fact, we were able to do it in previous generations. What we have found, from enterprise deployments around the world, is despite the fact that Wi-Fi 6 can support 80 and even 160 megahertz channels, 40 is really the sweet spot. And it's the sweet spot because I've got multiple APs that I am deploying in my environment, and I need to ensure that I don't have co-channel interference between those APs. And given the number of channels that I have in the 5 gig band today within that 500 megahertz, I simply can't get more than 40 without creating that co-channel interference problem. And that is tied specifically to the density. So I can't go any tighter than about 12 meter spacing between the APs, because again, that'll create that co-channel interference problem, which then will mean that I've got to drop down to 20 megahertz channels. And so, yes, if I get 500 megahertz and 6 gig, that's another radio that is providing more capacity, but I will still be limited to the 40 megahertz channels there. And so when you start looking at those scenarios that we talked about at the start, where we're really driving significantly higher bandwidth, It's not just about what do I need for the application today. It's how am I designing these networks that are taking me down the next 4, 5, 6, 7, up to 10 years. Looking at the acceleration that we're already seeing today, the recognition is we need to be able to have wider channels than 40 to support the future of where things are going. Now, one of the other things that we did just want to touch on briefly within the context of this is also what are things that people should be thinking about as they look to extend to Wi-Fi 6E and extend to the 6 gig band. One of the questions that does come up quite regularly is around really just the coverage of 6 gig as compared to 5 gig and 2.4. We already know that 2.4 has broader coverage than 5 gig just because of the penetration at the different frequencies. And so we do expect that certainly from a 5 to 6 difference as well. But the difference is not looking to be as pronounced. And so really the expectation is that we don't really see that there's going to be drastic changes in design, particularly again in that enterprise use case between what we do today and what we will do as 5 gig comes into the environment. One interesting thing that does come up in this is we find that enterprises are actually recognizing that the design they have really doesn't line up to how Wi-Fi is used today. Oftentimes those designs date back to the 802.11n days, almost 10 years ago. And the way that people have, started using Wi-Fi with Wi-Fi now as the primary access, multiple devices, more people, there's a recognition that you're not doing a redesign because of 6 gigahertz, rather you're doing a redesign because your design, even with Wi-Fi 6 today, because it was so old, probably doesn't line up to where you need to go. And so what we're finding is leveraging planning tools that are now starting to incorporate 6 gigahertz as well as site survey work to really look and understand not just how they deploy for 6 gigahertz, but really how they deploy for the needs of Wi-Fi today. Now, Hassan talked about the 6 gig device classes, and my intent is not to repeat what he did, but rather highlight another area that comes up when we talk to the enterprise today around moving into 6 gig, and that is actually talking about support for APs with external antenna, where we need to be able to shape the coverage, and also outdoor support. And so that goes to, two of the things that Hassan was talking about, the low power indoor and the standard power AP. And so really, the point to make here is that customers are already looking, people that are deploying Wi-Fi networks are already looking to extend into 6 gigahertz. And they're already recognizing that in my areas where today I would use external antennas or have outdoor APs, when do I get to bring 6 gigahertz there? So, I guess the piece that I really want to get you all to recognize is there is already demand for 6 gig beyond what has just been opened up today. So just, really interesting how customers are already, actively trying to take advantage of 6 gig. The other interesting thing that I think is worth highlighting is the implications from a security side. And really you need to think about where this is coming from. One of the best things that I think the Wi-Fi Alliance did when they created the certification standard around Wi-Fi 6 is that they tightly coupled it to the brand new wireless security standard, WPA3. And so the implication there was that any Wi-Fi 6 certified device was also a WPA3 certified device and gaining the benefits and enhancements to wireless security. Now, the interesting thing with Wi-Fi 6E is when you look specifically at the 6 gig band, the starting point is Wi-Fi 6. There is no legacy in the 6 gig band because there's no way for you to take an 802.11n client that you might have and have it talk to the 6 gig band. You can't take an 802.11ac access point and have it, talk on the 6 gig band. So 6 gigahertz starts with Wi-Fi 6, which means that it also starts with WPA3. And that creates some interesting discussions with people, looking at how they deploy today, because they can't, there is no WPA2 now in 6 gig. They can still support it in 2.4 and 5, just not in 6. And WPA3 also means there's no open network, which is typically what you see in public Wi-Fi. And I guess, the point here is this isn't actually a big deal because, again, all the Wi-Fi 6E client devices by definition will support WPA3, and they will support opportunistic wireless encryption, which replaces open. But I highlight it because it is somewhat of a surprise for people that, haven't really thought through, really what comes with 6 gig. And I view this really as a benefit. Not having legacy in the 6 gig band not only means that we've got really clean spectrum, but it means we're not dealing with, all of the issues that have come before. So it makes a great starting point for Wi-Fi to begin anew. Now, on the topic of the public networks, one last thing that I wanted to highlight actually comes from another of the industry organizations, the Wireless Broadband Alliance, which is actually looking at the next generation of a public Wi-Fi through a technology called open roaming. And open roaming, the whole idea behind it is how do we simplify access to wireless networks so that it works exactly as seamlessly as access to a 4G or 5G network is today. And interestingly, huge interest from the service provider side as they're looking at how do they provide seamless roaming for their customers onto these public Wi-Fi networks. And the great example of that, actually, it was just a few months ago at Mobile World Congress in Barcelona. So here is, the premier 5G conference. Everyone in the Fair of Barcelona were running on Wi-Fi, and open roaming was what enabled people to get onto that Wi-Fi network. There's already, some good adoption from service providers around the world. And in fact, the WBA has found an increase in their membership, not just from a service provider angle, but also just looking at enterprises and businesses and organizations as they look to leverage open roaming to provide that seamless connectivity experience as well. So that's just a little bit around the how, and how we take this technology, why, we see it so important, and how we can actually make it happen. So with that, I'll hand back over to APT, and if there are questions that we can answer. Thank you very much.
Thank you, Mark and Hassan, for the interesting discussion. Would you like to take some more questions from the chat box? We have questions from Alex. I don't know whether you have covered that.
I'm just taking a look at what we've got. If there are any questions, really good question. Do you need a fiber optic network, to provide the necessary backhaul throughput, to support Wi-Fi 6E and the advances in the speeds that we're getting, particularly in countries that don't have the fiber penetration? Well, this just goes back to why, pretty much everyone that's involved in driving Wi-Fi and 6 gig view that there's this complementary benefit with 5G, because in those countries, 5G is the perfect backhaul solution. That is, how, and even in countries where there is huge fiber penetration, we are finding that 5G is being deployed as a secondary, and in some cases even a primary backhaul, depending on the environment and the use case. So yeah, even if the fiber isn't there, I mean, that's part of the benefit of 5G. And I guess if there's one message to take away from this, no one who's pushing for Wi-Fi in the whole 1200 megahertz of the 6 gig band is somehow suggesting that it replaces 5G. We're just saying that we want the 6 gig for Wi-Fi, and there's plenty other spectrum for the 5G, and we see 5G as critical to the broader ecosystem. It's about all the wireless technologies and how they work together.
Thank you, Mark. We have a question from Martha Soares. Martha, please.
Thank you so much. It's not exactly a question. I just wanted to add on the answer about what happened with countries that don't have a lot of fiber penetration. We have been reviewing that case in many locations. And indeed, what we have found is that Wi-Fi is one of the main technologies used for rural connectivity and for affordable connectivity. So, for example, let me give you, we made a study for Indonesia, and we were trying to assess, so we had studied to assess the economic value or the economic contribution of dedicating the 1200 megahertz of the 6 gigahertz band. And we found that there is an impact on closing the digital divide. So for example, in Indonesia, an incremental of 1,145,000 Indonesians would be able to gain access to the internet if there is more spectrum for Wi-Fi, because then we could have better performance at public hotspots. So I just would like to say Wi-Fi is a technology for last mile to connect devices, and it combines, it works very well with any other technology. It could be fiber to the home, that's great if there is. In isolated areas, it could be with satellite backhaul or with fixed wireless access. And for many applications, it goes through mobile networks. And also not all the connections will go through an access point. We are also expecting to have connections, for example, between very low power devices and the smartphone, or very low power devices in an ad hoc network for industrial applications. So those are some additional comments on that question.
Thank you, Martha. We have a question from Alex Orange. He wants you to expand on why you are confident that LPI and VLP Wi-Fi 6E or 7 power classes can coexist with incumbent satellite links.
So I did touch on that at the start of the second piece there. And again, that goes back to a combination of, the work being done on AFC today. And as I noted, the work specifically on deploying that in the US, I think, we'll see as a great test case and proof point of that, as well as all the studies that went before. Martha, I don't know if you wanted to add something in that as well.
I think it was covered. Thank you so much, Mark. And even Alex, I think he replied saying that he would like to join for the third session about AFC.
Thank you. I think we are almost, it's almost 11:30 a.m. But before that, I have one question. It's related to the Wi-Fi 6 and 7. By introducing this Wi-Fi 6 or 7, I think we are basically trying to offload new traffic from the 2.4 gigahertz or 5 gigahertz. Do you think those legacy spectrums like 2.4 gigahertz should be repurposed for wider adoption of lower data rates such as IoT devices? Has the time arrived? Any thoughts on this, Mark or Hassan?
So I'll touch on it first, and Hassan might have some different views. But as a starting point, one of the things that Hassan covered for Wi-Fi 7 is looking at multi-link operation and the idea that we can actually have full duplex Wi-Fi connectivity by leveraging both a 5G and a 5 gigahertz and a 6 gigahertz radio simultaneously for the uplink and downlink. But the other piece goes to, it's all about increasing capacity. And it ties into some of the changes that Wi-Fi 6 brought with OFDMA. And so, you know, while 2.4 had always been problematic because we only had 3 channels to play with, because OFDMA now allows us to kind of reduce that 20 megahertz channels, individual clients can, you know, have their own much smaller resource unit. What we're seeing actually is that 2.4 is great for IoT scenarios, particularly when it's more lower data rate, you know, in the IoT sensor type space. So I think there's still benefit in maintaining those, as, you know, the new standards drive greater efficiency in how we use all 3 of the bands. Hassan, maybe a chipset view.
Sure. I think I just want to make sure the question was regard to how to improve and guarantee reliability and determinism for IoT application. Is that correct?
I think it was more around if we're moving to 6 gig, should we be repurposing 2.4 and 5, or do we keep those for Wi-Fi as well? Really unlicensed use.
Sure. I think that so today, as Mark mentioned, like the progression of Wi-Fi technology is assuming that that we have tri-band operation, and as Mark mentioned, some of the features like MLO are the features that are basically are provisioned to achieve reliability, higher throughput, and better latency. And we can also consider like different bands for different types of coverage, or for like dense like high throughput type of capacity limited basically coverage or deployment. Like we can use the higher bands, and the lower bands with better propagation environment can be used for basically coverage limited type of scenarios, and complementing each other and optimally support all the services. So that is what I recommend. And also we know that Wi-Fi is giving is trying to basically implement a general type of technology that addresses different use cases, not a specific class of use cases. And for that, it require basically, it require the operation in different bands. So I hope this is useful.
And I think, Hassan, that touches into, there was a question from Sean from IMDA, and I think, you know, what you just said there ties into that as well.
Yeah, with regard to Sean's question, I was trying to make sure like which question we are addressing. With regard to Sean's question, of course, we extensively went through what is the steps and plans for Wi-Fi technology toward like enabling and improving basically reliability and determinism. And of course, all those features that are listed, and you will have access to the presentations, are designed specifically to offer basically what is required for industrial IoT and all those like application for factory environment or any other types of enterprise deployments.
Yeah.
Thank you, Hassan. Do we have any more questions? Can I request participants? We have a question from Kwa Newman. Can I read the question? The question says, are there global standards for compliance for Wi-Fi 6E devices available to keep the incumbent services like satellite connections keep working?
Maybe I can address that quickly. There has been different studies that are conducted, like in US, Europe, and other regions, to address the coexistence, investigate coexistence with satellite, as well as like other incumbent services. Satellite incumbent, like the characteristic for satellite as an incumbent scenario is more or less similar globally. All those studies are showing that with the provisions that are already included for those countries that adopted the 6 GHz band for RLAN operation, with all those provisions, the coexistence with satellite is achieved, guaranteed, with a good margin, actually. And again, those studies are available for US, Europe, and I think that can be applied to other regions, like I believe the question was for Vietnam.
And again, I guess that's just another plug for episode 3, which will really show how AFC works and operates. Chris Szymanski from Broadcom's got some great visualizations, that actually show, how we are looking at, a specific site and what channels would be safe to use without creating any issues for incumbents like the satellites.
Thank you, Mark. Do we have any more questions from the participants? Maybe we'll take one last question. I think we do not have any questions, but let me ask a last question and then we will wrap up the session. Okay, right. I think that's a comment from Shin Tang. So the last question is, Mark, whenever there is a next generation or emerging technologies in the market or something new to be introduced, the most common questions that people ask is whether it is backward compatible. Are Wi-Fi 6E devices backward compatible? And also from the service or infrastructure provider point of view, does Wi-Fi 6E require new infrastructure, whether we need to replace all those core active devices such as router, firewall, or access points?
That's a really good question, and it's certainly one that I get almost on a daily basis. So there's 2 things to think about here. One is, in every generation of Wi-Fi, the new capabilities, like all the things that Hassan just shared on, where we're looking from a Wi-Fi 7 perspective, a lot of them are all tied to the physical layer and all tied to the chipsets. And so the result of that is it's not something that is software upgradable. That is something that, we really need to have a refresh of the hardware to support the new capabilities. For Wi-Fi 6E specifically, we've also now, obviously we're talking about bringing in an entirely new band to access. And so again, that does require, the need for a new radio, which does need to be replaced. But the important point that, and goes to your question is, it is all backwards compatible. And so a new deployment with Wi-Fi 6E supporting all 3 of the bands, legacy devices, going all the way back to 802.11b, are still going to be able to connect to that 2.4 gig radio that's on there. Obviously, as I touched on, you need a 6 gig radio to talk on 6 gig. But backwards compatibility is something that the Wi-Fi Alliance, and the 802.11 working groups have been focused on from the very beginning, which, of course, is a difference, particularly when you look at the private 5G space, because, you're going to have a lot of 5G devices that are 5G only and won't be able to talk to a 4G network.
Thank you, Mark. I think it's 11:34 Bangkok time. So let me thank Mark and Hassan for interesting discussion. Before we close, do Mark or Hassan have any last comment or anything, information sharing about next episode?
So the next episode will go on to 5G. Sorry, Hassan.
Go ahead. I'm sorry.
I was just going to say it covers really looking at how we see these technologies as interoperable and going into some more of the use cases. And so while lots of the questions were around AFC, which is episode 3, I think there's a lot of interesting content that everyone will hear in the next 2 weeks for episode 2. Sorry, Hassan, you were going to say?
No, I think you covered it. I just want to add very quickly to the previous question. Because of the proximity of the 6 gigahertz to 5 gigahertz band, most of the network design can be reused for 6E deployment of 6E based devices. So we don't need to do a lot of like a redesign of the network in the enterprise solution area. That's all. Thank you.
Thank you, Mark and Hassan, for those leading this interesting discussion. Certainly, I think with rapid adoption of technologies such as AR, VR, IoT, and I think the real-time collaboration, we certainly need more bandwidth, which currently seems limited. And I think indeed it is a giant leap when we move from Wi-Fi 6 to 6E or 7 in terms of network throughput. With this note, we come to the end of our session today. The presentations will be made available to all the participants on our website. And we also request the participants to complete a short survey form for us to improve based on feedbacks. I think the survey form is circulated in the chat box. And also, since the registration is open to all, we encourage everyone to participate in our upcoming web dialogue as well, and also encourage your colleagues and friends to attend this dialogue. So this brings us to the end of our first episode of Expanding the Wireless Access Opportunity, APT Web Dialogue Series. Thank you everyone for your kind presence, and we'll see you in the next episode. Until then, take care and bye-bye.
Thank you. Bye-bye.
Thank you. Bye.